All right, so another pathways problem. This is 1.24 from your book. At this point, you might be getting pretty comfortable with these conversion factor type problems, and that's a really good thing if you are. However, this particular problem really steps up the difficulty, so it's really going to test whether or not you're super proficient at these conversion factor business, because we've got different units. Sometimes the units are squared or cubed, and in other cases we're doing multiple conversions sort of at once. All right, so let's just sort of dive right in. This is a really good problem. If you understand what we're doing here and you're able to do it on your own and very proficient at it, you should start to feel pretty comfortable with your ability to do these unit conversions. Okay. Of course, you want to confirm that with practice, but if you're good at this, these are pretty tough problems, I think, for unit conversions, generally speaking. So let's just dive right in. We'll start with letter A. This is a 4-part problem. In letter A, we want to go from inches squared to meters squared. So you see this and you realize inches, meters. Okay, that's distance. Right? We've seen that sort of thing before. This is a little bit different, though, in that our units are going to be squared. That's actually going to make things a little bit more complicated. When you see these units that are squared or cubed, it's not handled exactly the same as the sort of single-dimensional units, or where they're raised to the first power. Okay. Now, what do we know about inches and meters? Just to start thinking about coming up with conversion factors. Okay. Well, 1 inch is 2.54 centimeters. Maybe you've already committed that to memory. Now, we want meters here. Centi, of course, is 1/100th of a meter, or 10 to the minus 2. So I think it would be safe to write on the board here that 1 inch is equal to 0.0254 meters. Now notice I dropped the centi unit, and that's because I moved the decimal place 2 spots to the left to account for the centi. So, 100th of a meter, the measured unit, right? So I can write that as a conversion factor between inches and meters. And that's a correct conversion factor. But what I want to ask you is, if this is true, is 1 square inch equal to 0.0254 square meters? Is that true or not? In fact, it's not. It's not true. We can convince ourselves of that by making a drawing. In this case, it's a box or a cube, because that's what I'm really measuring here, right? Surface area, inches, meters squared. Think about this cube. Let's give it some dimensions. Let's say it's 1 inch wide, and also exactly, it's not a cube, it's a square, 1 inch tall. So that's 1 inch by 1 inch. If I asked you to compute the area of that, okay, 1 inch by 1 inch, that is 1 inch squared, or 1 square inch. That is the surface area of that box, right? You with me on that? Simple stuff, right? Now, what if I asked you to consider that exact same dimension box, compute the surface area in meters squared? You would say, okay, I guess I can do that. I know that an inch is equal to this, so that must mean that dimension is 0.0254 meters, just like this dimension is 0.0254 meters. And then in such a case, the area in square meters is 0.0254 times itself for squared. Everybody see that? If you do the math on that, the answer that you get is 0.00064516 meters squared. So what we've just done is convinced ourselves that a 1 square inch area is equivalent physically to 0.000641516 meters square area. By drawing this picture, we've come up with our conversion factor. So 1 inch squared is not equal to this, but we now know that 1 inch squared is in fact equal to 0.000641516 meters squared. And I've now generated my conversion factor to use to convert between the units described in A. It's as simple as that, okay? Now, whenever you see these squared or cubed units, you have to realize that this type of thing could come into play. And you have to really be aware of that, okay? It's something that you really need to think about. Sometimes it's hard to generate the conversion factor. What I really have learned to do over the years to make this easier is to draw myself a picture like I did here. You can usually kind of linearly think your way through it. It makes life a lot easier. Okay, so I always encourage drawing little drawings, pictures to make things better. Nonetheless, that's part A. Let's talk part B now. Part B, we want to go from kilometers squared to centimeters squared. Here we have meters as our base units. That's the first thing I mentioned. So we're in the metric system, same base unit, but we have different prefixes. We have kilo and centi, right? Now kilo is a bigger unit. That's 10 to the 3 of something. Centi, smaller unit, 10 to the minus 2 of something. So there's this factor of 10 to the 5 between the two. And indeed, I could write that 10 to the 5 centimeters is physically equivalent to a kilometer. So if you walk a kilometer, you've also walked 10 to the 5 centimeters. Of course, 10 to the 5 is what? 1, 2, 3, 4, 5? What is that? 100,000 centimeters? Is it a kilometer? Okay. Just familiar with that. So if you've walked a kilometer, you've walked 10 to the 5 centimeters. So is this our conversion factor? I'd argue that it's not, again, because these are squared units. We're talking about a surface area. So we need to draw our picture again, right? So if I made this box let's do it the other way. 1 kilometer by 1 kilometer, that would be 1 kilometer squared. Right? 1 kilometer by 1 kilometer is a square kilometer. Now, how many square centimeters does that correspond to? Well, we know that there are 10 to the 5 centimeters in a kilometer. So we can define this box just by the centimeter unit instead of kilometer unit. And when we realize this, we can quickly see that 1 square kilometer is 10 to the 5th centimeter squared times itself. As a result, the conversion factor that we need to do subsequent calculations or conversions between these two units, that is kilometer squared and centimeter squared, is this. 1 square kilometer is physically equivalent to 10 to the 10th centimeter squared. Right? So same sort of thing as an A, as it turns out. Those two were pretty similar for the most part. All right, so let us move on then to C. This one's even more challenging. Wow. We need to go from miles per hour, which is of course a velocity. You might register that on your speedometer on your car, driving to class. We convert that into meters per second. Meters per second. How in the world are we going to do this? Now, first off, before we start, let's think about what makes this a little bit difficult. What is it that makes this difficult? Okay. Well, for one, we don't have just one unit of measure. Now we have two things that we're considering here. We've got miles and we've got hours. We've got a distance and we've got a time. And not only do we have two things, in both cases they're different in the desired units. Both of these could describe a velocity, just in a different distance and time base. All right, so we actually need to convert both of them if we're going to be successful. Now, what I'm going to try my best, there's several different ways that we can kind of go about this practically, okay? But what I'm going to try to do here is to be as sort of consistent as possible with my framework of how I've sort of told you to do this, okay? There's several different ways you can do this, and other ways may be considered a little bit easier, I suppose. But I'm going to try to be as consistent as possible, where I'm going to take an undesirable unit and multiply by a conversion factor, okay, to get our desirable unit. Which here's meters per second, okay? So if I'm going to tell you to do it this way, right, well, the next thing I would say is, okay, meters per second, my desirable unit, and my undesirable unit down here, miles per hour. That way this cancels, and the story's kind of concerned with this business of the conversion factor. Now the trick is that we got to figure out what numbers to put in there to make it work. So far I'm setting this up the same way, okay? But I got to figure out what numbers to put in there to make it work. Well, I'm not given any numbers in the problem, and I'm just given a bunch of information about converting between miles and meters and seconds and hours and so on and so forth. So how do I come up with that? Okay. Well, in some cases, what I can kind of encourage you to do is generate your own numerical factor, and the way I'm going to choose to do that here, just to make things simple, I'm going to think about a velocity of 1 mile per hour and try to figure out how many meters per second that corresponds to. Okay? Now the first thing I notice is that my time units are all messed up because I'm starting in hours and I want seconds. Right? So I'm going to have to do something about that. So the first thing I'm going to want to do here is to get rid of my hours units. And convert 2 seconds. Now notice what I'm doing here is I'm using another conversion factor. But here, I'm setting up the math so that this hour units cancel. That's a little bit different than what I've done over here with the conversion factor. But as long as they cancel out, they go away, and we're good with that, right? So if I multiply by this conversion factor, which is numbers which make this physically equivalent, we'll talk about that in a second, I would get rid of my hours and I would convert, my answer would be in miles per second, okay? And that gets me to the second time base, and that's sort of what I want. But the key here is that I now need to write some numbers in here, right? Well, remember, the numbers that I write in have to correspond to the same physical thing that I'm talking about, just different units. Well, what do I mean by that? Well, 1 hour, as it turns out, is physically equivalent to 3,600 seconds. 3,600, where did that come from? Well, we know that there's 60 minutes an hour, 60 seconds per minute. So how many seconds are there an hour? Well, 60 times 60, that's 3,600. Okay, so in doing this, I get rid of my hour units, and I'm going to convert the answer to that would be in miles per second. Everybody see that? Hopefully you can convince yourself of that. Now I'm still not done, and I don't have my desired units of meters per second because I'm still in miles per second. So I need to do a little bit more work. I need to go from miles into meters. So again, I'm going to set up my conversion factor so that the mile units cancel. Here it's in the numerator, here it's in the denominator. If you have one in each, they cancel out. My desirable units is in meters, that's my lowercase m right here in the numerator. So now I just need to again put numbers into this fraction which are physically equivalent. Let's see, do we have such number on the board? It looks like we don't, so we're going to have to actually come up with one, or at least write a new one. It just so happens that 1.609 kilometers is equal to 1 mile. Okay, so 1 mile is this many kilometers. Now notice it's a kilo base unit, means 1,000. So if I'm doing a conversion in my head, real fast, I multiply by 1,000, and 1,609 meters is physically equivalent to 1 mile. Alright, so now you see that if we work the units out, what comes through the calculation is meters per second. And that's what our desirable unit in our conversion factor is. Remember, we started with 1 mile per hour. That's why I put the 1 there, okay? So to figure out what that conversion factor is then, I need to take 1609 and divide it by 3600. And if I do the math on that, it looks like it works out to 0.4469 meters per second. So I write that in here, 0.4469 meters per second, and I'm in business. I've got myself a conversion factor to go between velocity units of meters per second and miles per hour. And it's really as simple as that. 0.4469 meters per second is equal to 1 mile an hour. And we could use that now to convert between these velocity units over and over again as we need, okay? So this was a little bit more difficult because we have 2 units that, and both of which we need to change. But nonetheless, if you go through this approach of using the fractions and conversion factors to deal with the units, I think you can reason your way through it pretty quickly once you get good at this conversion factor business. So practice with the easy ones and then try these more difficult ones. But if you get to the point where you're really good at this, that's really excellent news because that suggests that you're really mastering this topic. And that's what we want to see, okay? Because when you get to the exam, you're going to feel real comfortable with this type of problem. Historically, I mean, I can't predict for every single semester, right? But historically, this type of problem, could appear on an exam. You might expect that almost, okay? All right, but we've got, excuse me, one more of these that we want to consider. And this is a conversion factor between pounds per cubic foot and grams per cubic centimeter. Now you've probably seen this grams per cubic centimeter unit before. Where do we usually see that? We see that when we're talking about densities, right? The density of lead or the density of water. 1 gram per cubic centimeter. It's a measure of mass per volume of that substance, right? Well, this is also a measure of density. It's just in pounds per cubic foot. It's got the English base units instead of the metric, but it's still a density measurement. We just don't use that as much, so it's kind of strange to us, right, to see that. So how in the world could we go about making a conversion factor for this, right? Well, let's think about it. Let's start with the pounds per cubic foot units just for a second. And think about how we can convert away from this into this mathematically using conversion factors, this dimensional analysis approach. First thing I know, we don't want pounds units in our answers. We want gram units. So we're going to need to get rid of the pound units. That's our undesirable unit. And if I put a pound unit down here in the denominator, ultimately that's going to cancel out, right? And that's what I want. So I'm going to start with that, and I'm going to put my desired unit up here in the top of the fraction. And remember, I want grams. Now the trick is that I need to know what numbers to put here now. How do we relate grams and pounds? What's the conversion factor between these two units? Well, before I started this problem, I looked up in your textbook what that conversion factor is. It turns out that 1 pound is physically equivalent or equal to 0.4536 kilograms. Now, this is the gram base unit, but we've got this kilo out in front. That multiplies by 1,000, basically, okay? So what that means for us is that if I move the decimal place 3 spots, 453.6 grams is physically equivalent to a pound. That step, then, has now successfully allowed me to convert into gram units from pound units. So if I stop there, my answer, if I was actually computing something, I had a number here and I multiply it by this, my answer would be in what units? What? Grams per cubic foot. And that's a density unit as well. Not very commonly used, but that's what my answer would be. Now that's not what I want though. I want grams per what? Cubic centimeter. Alright, so I need to keep converting to convert my second unit. Right? Got to get rid of my cubic feet. Now how do I achieve that mathematically? Well, it looks like in the math that if I put a cubic foot up here, it would ultimately cancel out. And then I could have a cubic centimeter down here in the denominator, and that would carry through. And if I did the math, if I put numbers here and did the math, I would end up with units of grams per cubic centimeter, and lo and behold, that's what we want. So the last thing that we need to do is figure out what numbers to put in this fraction to make this work. Everybody see that? Okay, now how in the world are we going to go about doing this? Okay, how can we figure this out? Well, from our previous experience, we've noticed what's true about these squared and cubed units. That you got to be a little bit careful with dimensionality, whether it's your first to second, third dimension. Now think about these cube units. What do they usually tell us about? They tell us about a volume, right? So maybe it would be helpful if I can use my keen artistic skills here to draw a cube. So this is my cube. It has a volume associated with it. Now if I'm going to compute that volume, I could do length times width times height. And that would be the volume of my cube in whatever units I measure those 3 dimensions with. Okay? So in this problem, we're measuring really in 2 different dimensions, aren't we? We're measuring in feet and centimeters. So what if I decided that this cube, this imaginary cube that I'm considering, is 1 foot tall, 1 foot wide, and 1 foot deep? Wouldn't it be wise to say that that cube in that case is 1 cubic foot? Right? Makes sense. It's 1 foot by 1 foot by 1 foot, that's 1 cubic foot. 1 foot to the third power. Got it? Alright, now you can see where I'm headed with this already based on our last problem, I hope. Can't I also define this cube in cubic centimeters as well? Think about how to do that. Well, what do I know about 1 foot? A foot is 12 inches. Right? You with me on that, right? In addition, 1 inch is 2.54 centimeters. So if I have 12 inches in a foot, that corresponds to 30.48 centimeters. So 1 foot is physically equivalent to 30.48 centimeters. So now I can describe this cube in centimeter units, not in feet unit anymore. So it's 30.48 centimeters tall. It's also 30.48 centimeters wide. And in addition, it's 30.48 centimeters deep. So what's the volume of that cube in centimeters? Or cubic centimeters. It's 30.48 cubed. Now if you do the math on that, it works out to 28,316.8 is what I've got here. 28,316.8. That is how many cubic centimeters are present within a 1 cubic foot cube, right? So 1 cubic foot then can be said to be physically equivalent to 28,316.8 cubic centimeters. And you can see now that if we combine this and this, or this divided by this, we would have our single number that would serve as our conversion factor between pounds per cubic foot and grams per cubic centimeter. Alright, so again, these problems really ramp up the difficulty quite a bit. I hope that you found this video useful, and I certainly encourage you to keep practicing this, because this skill is, again, an important life skill for you. And usually you will see this on the exam. In many cases, maybe several problems on an exam, okay? So in terms of thinking towards your exam already, this could very possibly show up. So get good at it.